Greetings of the day. Myself, Kumar ji, Assistant Professor from the Department of Mechanical Engineering, Madanapalli Institute of Technology. Today, I'm going to take about the engineering graphics, the overall view about the engineering graphics. First, the flow of presentation. First, introduction about the engineering graphics and the various projection methods we used in engineering graphics: orthographic projection, isometric projection, lettering, projections of points, lines, planes, as well as solids. So, what is engineering graphics? What is the need of engineering graphics? First of all, engineering graphics is technically referred as engineering drawing. In a simple form, we can say engineering drawing. For any manufacturing of any component, the very first stage is making a drawing of the component. Actually, engineering graphics is the graphical representation of solutions, engineering systems, components according to the required national and international standards of practice. So we need to make any component, any manufacturing, the very first beginning stage is drawing of that particular component. So it satisfy the human needs also. So these drawings are produced with the purpose of solving specific human needs. So such examples are the drawings are used in agricultural field, energy, shelter, transportation, healthcare, education, etc. So for any manufacturing of component, the very first stage is the drawing of that component. So that drawing is by means of engineering graphics. So basic knowledge for drafting. So first we need to know the difference between the graphic language and the word language. So in a graphic language, actually we are derived by means of different line types, different projection methods, different geometrical construction. So for a graphical language, these three things are very essential. But when come to the word language, just lettering. So we want to say anything about the manufacturing or about the drawing just by means of some sentences lettering in by means of the word languages. So start from the projection methods. So we have different projection methods. Start from the perspective projections, parallel line, oblique, orthographic, isometric or axonometric, and multi-view. So let us see one by one what are the different projection methods. So first one is orthographic projection. So in orthographic projection, simply the object and the viewer are perpendicular to each other. And technically we can say the projection technique in which the parallel lines of the sides are perpendicular to the projection plane. When the object and the viewer are perpendicular to each other, we can draw the orthographic projection. Say this example, when we draw a component in a front direction, so or for top view or side view, so how the objects are looks like when object and the viewer are perpendicular to each other. So this is a simple example about the orthographic projection. When come to the isometric projection, when the object and the viewer are slightly inclined to each other. Say for example, normally 30-degree inclined, the object and the viewers are 30-degree inclined to each other. We can see all the dimension in a single view. So the main advantages in isometric or axonometric view is it is very easy to understand, and the shape and angle are slightly distortion, that is in disadvantage state. For example, this drawing, when we look at the hole, it become a circular hole is become an ellipse because of the inclination. Some distortions of the shape will come. This is the small drawbacks in case of the isometric view. But in case of the isometric view, we can see all the dimension in single view. That is a major difference between orthographic and isometric view. When come to the multi-view drawings, so in a multi-view drawings, it represents the accurate shape and the size. Exactly what is the component design, that same will be reflected here. So multi-view drawings are also disadvantages. It requires practices in writing and reading. So that is a small disadvantage in case of the multi-view drawings. So in example, the front view as well as the side view and the top view, all three views are available in multi-view drawings. Come to the basic line types. So when we take any component, the component is a combination of different lines. So first line is a continuous thick line or object line. So for all the drawings should be very thick, that is a visible line. So for the skeleton of the drawings are made by means of the continuous thick line, whereas the continuous thin line is used for the dimensions, extension lines, leader line. These lines are made by continuous thin line. In hidden parts, hidden line, invisible parts, so dash thick line we have hidden lines. Some objects are hidden, some parts are hidden. When we are looking the front view, top view or side view, something are hidden that is inside, but it is not visible in any view. So that case we can use the hidden lines. Then in the same chain, thin lines for center line, that is an axis line. So for vertical axis and horizontal axis, we can use the center line for representing. This is an example of line conversion in engineering drawing. So first object line or visible line. So for all the outer lines are made by means of thick line, that is a visible line, that is an object line. In simply say, that is called object line. In case of the second is a dimension line, it's a thin line. So we need to highlight the different dimensioning systems are there, but anyway we need to highlight the dimensions by means of dimension line. While draw the dimension line, we need to concentrate about the extension line also, that is also very thin line. Then the leader line. Leader line is for representing the diameter, radius values, as well as the center line for axis, central axis as well as y axis, horizontal and vertical axis. So this is an example of different line types, how it is used in drawings. And next come to the types of drawing. So when we come to the types of drawing, actually the freehand drawing first is very basic and simple is freehand sketches. So without using any instruments, how we drawn manually, that is called freehand sketching. The lines are sketched without using any instrument or anything other than pencil and eraser. That is the only one requirement, freehand sketching. When come to the instrument drawing, so we use a drafter. In olden days we use a drafters for instruments used to draw the straight lines, circles, curves. Then when in accurate dimension we can use all instrument. So the drawings are usually made to drafter scale, that is called instrument drawing. And the recent days we have the computer drawing. The drawings are usually made by commercial software such as AutoCAD or SolidWorks. So that is a computer drawing. So using the softwares, we can draw the same diagram. Instead of drafter, we can use AutoCAD and SolidWorks for drawing, design purpose. So and then come to the lettering. So what is the need of lettering in engineering graphics? So it gives a legibility, uniformity, then rapidity of execution, then suitability for reproduction. These all are important while taking the lettering. And also we have some standard height for lettering height, maximum, that is height in terms of capital letters, we can use 5 mm. Then lowercase letter we can use 3.5. Then space between the characters is 1 mm. Minimum spacing of the baseline 7 mm. Minimum spacing between the words 3. Thickness of the line is 0.5. So like that we use some standard lettering style as well as standard lettering heights for uniformity of the drawing. When come to the dimensioning, then dimensioning is a very important factor in case of all drawings. Without knowing the dimension, the manufacturing is not possible. So first we can come to the projection lines. So the projection line in the same way that dimension line, leader line, dimension line with termination arrowheads and origin indication dimensions. So here we can use all these are comes under dimensioning. We have a parallel line dimensioning, we have many types of dimensioning. Anyway, dimensioning is the different types of lines we can use here. Then come to the types of dimensioning. We have a chain, parallel dimensioning. These are all the two main dimensioning. Then in addition to that, different methods also they are aligned and unidirectional. Then for indication of the shapes, so how we can indicate the diameter, radius, square, then spherical diameter, spherical radius, we use some standard symbols. And come to the orthographic projection. So we have a horizontal plane and vertical plane as well as the projection plane. So the front view, when the object is looking from the direction of the front view will be appear on the vertical plane. So the image, the front view will be on VP. In the same way, the top view will be on HP and the side view will be on PP. PP in the sense projection planes. So these three views are very important for any drawing, the front view, top view as well as side view. So when come to the quadrant in case of the orthographic projection, the quadrant are taking the major role. First quadrant, second, third and fourth quadrant. So what is in the first quadrant? How can we describe the first quadrant? The first quadrant is above HP in front of the VP. When the point or line, whatever it is, any object is placed in the first quadrant, we can describe the point is above HP and in front of VP. In the same way, when we come to the second quadrant, the same point, line or any object, it is placed in the second quadrant, above HP, then behind VP. The same way, third quadrant is below HP, behind VP. Fourth quadrant is below HP, in front of VP. So depends on the quadrant, we can say the projection. If any component is placed in the first quadrant, that is called the first angle projection. Second quadrant means second angle projection. Third angle projection. Fourth angle projection. So normally we use first angle projection and the third angle projection in many drawings. So first angle and the third angle is very important. So first angle, the object is placed above HP and in front of VP. So the front view is on VP and the top view on HP. Anyway, the front view is always above XY line and top view is always below XY line. That is called first angle projection. When come to the third angle projection, just a reverse of first angle projection. The front view is coming below XY line and the top view is coming above XY line. This is the two major differences. So when we come to the orthographic projection, so we use four quadrants theory. The four quadrants theory, first quadrant, second, third quadrant and fourth quadrant. So how can we describe the first quadrant? So the first quadrant is normally above HP, above horizontal plane and in front of vertical plane, above HP and in front of VP. When any object is placed in the first quadrant, so that is called first angle projection. In the same way, when any object, it may be a point, line or any solid, if it is placed in the second quadrant, that is called a second angle projection. So we can describe the second quadrant above HP, behind VP. The same way, third quadrant below HP, behind VP. So just a reverse of first quadrant. Then fourth quadrant is below HP, in front of VP. So this is the four quadrants. So we can place the objects in four quadrants. Then we can get the different front view and as well as top views. So when we come to the in detail about the first quadrant, when any object is placed above HP in front of VP, that is comes under first angle projection. So in first angle projection, the front view is above XY line and the top view is below XY line. Just a reverse of the first quadrant is actually the third quadrant. In the third quadrant, below HP and behind VP, so objects are, the front view is coming below XY line and the top view is coming above XY line. This is the difference between the first and the third angle projections. So in the third angle projection, we know that the reverse of the first quadrant. So that will be explained. So next we need to move to projections of points. In case of the projections of point, so we use this quadrant theory in projections of point. First, we took the point in the first quadrant. So first quadrant is above HP and in front of VP. So what happened when the above HP and in front of VP? The point A, suppose say for example the point A is in first quadrant. When the object is looking from the direction of the front view, you will get the A dash. A dash is the front view on VP and A top view on HP. After getting the front and top view, we are going to rotate the HP horizontal plane by 90-degree clockwise. So when we are going to rotate 90-degree clockwise, automatically the top view is coming below XY line. The front view is above XY line and top view is below XY line. This is called the first quadrant. What happened when the point is placed in the second quadrant? Say for example, the same point A is placed in the second quadrant, that is above HP and behind VP. So the direction of the front view is remains same. See, all the planes are transparent. It's a transparent plane. So when we can see the same direction of the front view A dash will be on the VP the same way and the top view A on HP. After getting the front and top view, we are going to rotate the HP by 90-degree again clockwise. So when we are going to rotate 90-degree again clockwise, the A is also going up. So both the front view A dash as well as A is coming above XY line. That is called the second quadrant. In the third quadrant, just a reverse of the first quadrant. So because of all the planes are transparent, the direction of the front view never changes. It remains constant. So the direction of the front view, when we are looking the object from the front direction, the A dash on VP, again A is on HP. But after getting the front and top view, we are rotating the horizontal plane HP by again 90-degree clockwise. In all the cases, we are going to rotate the HP by 90-degree clockwise. So when you rotate 90-degree clockwise, the top view will be moving up. So top view is above XY line and front view is below XY line, just a reverse of first quadrant. When we come to the fourth quadrant, the same as like the, because of the transparent plane, we can see the A dash as well as A. After getting the front and the top view, we are moving to rotate HP by 90-degree clockwise, so that top view will be coming down. So both the front as well as the top view will be coming down, just a reverse of second quadrant. So in second quadrant, both the front and top view will be coming above XY line. In the fourth quadrant, both are coming below XY line. That is the different projection of points in four quadrants. So in case of the projections of points, so how the points are rotated, that is already explained. But anyway, we have some 3D views. So how it looks like, the point is on VP, the point is on HP. Anyway, so we have some other examples. When it is on HP on VP, what happened? So this is an example. The same way, after getting the front and top view, we are going to rotate the horizontal plane by 90-degree clockwise. So just a brief introduction, brief discussion about the positions of straight lines. When we come to the projections of straight line, again we have 5 to 6 different cases are there in case of the projections of line. So first case is, a line is perpendicular to HP and parallel to VP. The vertical line is perpendicular to HP and parallel to VP. Then second case, line parallel to both HP and VP. Then line inclined to HP and parallel to VP. Then line inclined to VP parallel to HP, and line inclined to both HP and VP. The last case is very important as per the exam point of view. Line inclined to both HP and VP. But anyway, we need to know all these simple cases, then only we can solve the problem in case of line inclined to both HP and VP. So let us see one by one. First case, a line perpendicular to HP and parallel to VP. So the point, the red color line, that is perpendicular to HP. So when we are looking the point from the direction of the front view, so the line, the straight line will be appear in the front view. And top view is obviously a dot that will be on HP. So after getting the front and top view, as our previous discussion, same like rotating the horizontal plane by 90-degree clockwise. When we are going to rotate, the top view is automatically coming down. So front view is a straight line and the top view is the dot. In the case to a line parallel to both HP and VP, in case of these, so both the front and top view will be a straight line. Because of parallel to both HP and VP, both the front and top view will be a straight line. So come to the next case, a line inclined to HP and parallel to VP. So this case, the inclined line, the front view will be the inclined line and top view will be a line with reduced length. Because of the inclination, the true length is not visible in the top view. Because of the inclination, the true length, say for example, the true length is 75 mm in the front view, the top view will be less than 75 because of the inclination. In the same way, line inclined to VP and parallel to HP, the front view is be a reduced line. So in this case, we can start the problem from the top view. Why? Because the true length of the line will be appear only in the top view. In the front view, only reduced line will be coming. So we can start the problem from the top view, then the reduced line we can project, then we will get the point. And when come to the last case, inclined to both HP and VP. In both the cases, we cannot see the true length. So in both front view as well as top view, both are reduced in length because of the inclination. So we have a different types of problems, different methods, different datas we use for line inclined to both HP and VP. So we have more than 5 to 6 types of problems are there in case of the line inclined to both HP, VP. Anyway, in both the views, it is inclined. Front view as well as the top view is inclined to both the planes. So we can get the front view as well as top view in both the case. In both the front and top view will be reduced in length. True length is not coming. In both the cases, it is reduced in length. Anyway, we draw the true length also, but the front and top view will be reduced in size. So this is a simple example in case of the projections of straight line. So both the front as well as the top view will be reduced in length because of the inclination. So by means of rotating line method, the name of the method, how we will get the front and top view, by means of rotating the rotating line method. In a simple logic, when we are going to rotate the true length, we will get the views. Say for example, we are going to rotate the true length, front view true length means you will get the top view. In the same way, when you are going to rotate the top view true length means we will get the front view. This is a simple logic behind the rotating line method. So this is another example. And the one important point here, but we need to know the difference between the alpha, beta, theta, and pi. So first alpha. So alpha is nothing but inclination with the front view, the inclination of angle with the HP with the front view. In theta is nothing but true length, inclination of HP with true length. In the same way, beta is top view angle, top view inclination of top view with VP. In pi is true length inclination with VP. So these four are very important: alpha, beta, theta, and pi. So we need to clear understand about these four angles. So next, projections of plane. After first projections of points, then line, then the next level is projections of plane. Actually, the plane is the surface. In simple term, plane is a surface. We are not taking the thickness into account. It is also a 2D component. Plane is also a 2D component. A plane is a two-dimensional object having length and breadth only. So thickness is it's not important. It is thickness is always negligible. So we have a different types of plane. Say for example, starts from the square plane, pentagon plane, hexagon plane, circular plane, triangle, then rectangle. So like that, we have many types of planes. So how the planes are, we can how we draw the planes front view, top view in this using AutoCAD. So this is some examples here how it is the front and top view will be coming. So the different cases of projections of rectangle. So first is the surface is parallel to HP and the surface is inclined to HP and the surface is inclined to VP. So like these cases. So first case, when the plane is parallel to HP and perpendicular to VP, this case the front view is a straight line and the top view is the true shape of the plane. So where we can start the problem? So first we can draw the top view and then front view. Why? Because the true shape is available only in the top view. The front view true shape is not coming. Front view is a straight line. We cannot say which plane is it. It may be a rectangle or triangle or circle. We can't say. So that's why where the true shape is available, that is the starting point. So first draw the top view, then front view. While coming to the second case, it is inclined. The plane is inclined to HP. In this case also, we can start the problem first top view and then front view. Then the same next case, inclined to both HP and VP. First we draw the initial position, then secondary position, and then finally we can come to the inclined to both HP and VP. So the next, the projections of solids. After the points, lines, planes, the next stage of engineering graphics is projections of solids. So when we come to the projections of solids, actually the projections of solid is divided by two family. One is a cylinder family and another one is a cone family. So all the prisms are comes under cylinder family and all cones are comes under pyramid family. So this is the major classification, cylinder and a cone. In addition to that, we have the hexahedron as well as the tetrahedron also. So we can divide these two families by means of cylinder and cone only. So this is the dimensional parameter, some examples, how the square pyramids, how the cylinder, how the cone, and what are all the different parameters we are going to take. The rectangular face, longer edge, corner, base edge, base corner, in the same way apex point. So these are all the terms we used in case of the solids. And this is the simple general pattern, general position, how the solids we are going to draw. First, the solid cone, initial position, then inclined to HP only, then after that inclined to VP. So these all are comes under inclined to both HP and VP. Anyway, we cannot directly draw the inclined with both the HP and VP. So first initial position, then secondary inclined to HP only, and the third inclined to VP only. So like that we can divide. Then next stage is after a section of solid, after projections of solid, the next stage is section of solids. So what is the use of the section of solid? We need to know the interior portion of the solid. We can't say when we are looking any object, it may be a hollow or a solid. The first examination is we need to understand whether the solid is a hollow or solid object. After introducing cutting plane, after open, then only we can say it is a hollow or a solid. So maximum in section of solids, we are introducing a cutting plane in different angles. So based on the angle, the remaining portions will be coming. So that if you are going to take an example, say for example of when you are going to cut the cylinder with some inclination, the true shape will be coming as like elliptical shape. So it is depends on the angle of angle of cutting plane, as well as depends on the solid. So we will get different true shapes. We will get. So next stage is development of the surfaces. After section of solids, the next level is development of the surfaces. We are going to open the surfaces. So for example, when you are going to open the cylinder, we will get one rectangle. How we are going to open it? By use some formula. Say for example, in case of the cylinder, we can use pi d. That perimeter is the formula for opening the cylinder. And in case of the cone, in case of the pyramids, we use the theta is equal to r by l into 360. So where r is equal to base circle radius and l is the slant height. Using this formula, we can open the surfaces. Say that is the next one for prisms. Prisms also we use depends on the number of sides. Say for example, if it is hexagon and the each base side is 40 mm means, so 6 into 40. So like that we can divide. In case of cube also, in case of all the prisms as well as the cube, we can divide by number of sides. We will get the development of the surfaces. Thank you for this opportunity. So I'll close my session. Thank you.